Mr. Rups here, and we are going to talk about arc lengths and areas and radian degree measures today. So just a quick review of some definitions. So when we have a circle, when I have a line that connects an edge of the circle to another point on the circle, this is called a chord. The special chord you know is a diameter. That's a special chord. But this is chord AB. This here, when it goes around, this is arc AB. And so here's the notation for arc AB. I also have something, so if I consider there's a radius and a radius for the center, that little part that is shaded there, this part is called a segment. It's only that little wedge type piece there. A sector is the whole slice of pie here. The entire slice is the sector. The segment is the sector, subtract the triangle. And then finally, from the center of the circle, this angle here is called the central angle. So any angle from the center of the circle is called the central angle. And what we would have learned from the past is that if I want to find the formula for the length of this arc here, or maybe it's better to do it on this one. If I want this arc L, well, I know that L to an angle, okay, this is the part to the part of the angle. Well, the whole circumference is 2 pi r, and the entire circle is 360. So this is a proportion that I can set up quite nicely. So the part of the length to the part of the angle, and they're proportional, are equal to the proportion of the entire to the entire degree. And so if I multiply by theta, I can say that L is equal to 2 pi r over 360 times theta. Similarly, I could replace, as opposed to doing arc length, if I wanted to do the area, I could change this formula here. I could change it from area to an area. And the same thing holds true, that it would be pi r squared over 360 times theta. But you don't have to memorize these formulas because you will see them in your formula booklet. Okay, so here they are in degrees, and so it's written just slightly different, but this is the same idea. You can see clearly from here that the formula booklet gives you the formulas for arc length and area of a sector, as opposed to the sector. Okay, so let's try an actual example here. We have to use those formulas. So let me copy this over, go down, make sure we set it up correctly. Okay, so in this problem here, we're given the sector of the circle to the right with a radius r and an angle, central angle of theta. The length of the arc of the circle is 12 centimeters. So this arc is 12. So right away, I can go to my formula here and go that 12 is equal to theta unknown over 360 times 2 pi, and r is also unknown. And I'm told the sector area is 108. So this area is 108. So then using the other formula, I can say 108 is equal to theta over 360 times pi r squared. And so now my job is to solve for r and theta. Well, I have two equations, two unknowns, so I'm going to be able to solve for it. And so one of the cool kind of tricks that I can do, something you may not have thought of before, I'm going to do a substitution. But if you notice, this theta is the same as this theta, but it's also the same as this 360, and this 360, and this pi, and this pi. So I'm going to substitute, I'm going to rearrange this equation for theta over 360 pi. I'm going to rearrange them both that way. I'm going to make this, I'm going to take this one and just divide by 2 to get rid of the 2. I don't have to deal with it. So 6 is going to be theta times pi over 360 r. And here I know actually I'll divide by r as well. I'm going to divide by 2r. So I divide by the r. And so now I know that 6 over r is equal to pi times theta over 360. So this piece here is equal to 6r. So as opposed to substitute all of just theta, I'm going to substitute all of this because they have to be the same. And so then I can say 108. This is 6 over r times r squared, which they cancel, so I know 6r is 108. Now if I divide by 6, I can tell, because I did it earlier, that this is going to be 18. So r is 18. If I take this either one now to find my theta, I can go to this one here since it looks fairly straightforward. Over 18 is equal to theta pi over 360. I'm looking for theta now. This is 1/3 equal to 360. Theta over this. If I multiply by 360, I get 360 over 3 is theta pi. And 120 is equal to theta pi, dividing by pi both sides. And I can say the exact value is 120 over pi, which is approximately 38.2 degrees. Okay? And so ultimately we just use our formulas here to get two equations with two unknowns, and we solve for r and theta.